Ještě okamžik. Dámy a pánové, krásné odpoledne. Já vás vítám tady v těch nádherných prostorách brněnského planetária. Dnes nás čeká debata, která se zaměří na globální výzvy v oblasti životního prostředí a zdraví. A celý ten program bude v angličtině, tak mi dovolte, abych rovnou přešla tedy do anglického jazyka. So, good afternoon, everyone. It's my great pleasure to welcome you here at this beautiful place of Brno Observatory and Planetarium. It's a special place for really special event because we have wonderful guests. Today we are going to focus on global challenges concerning environment and health, and we have leading experts for this topic. So it's my honor and pleasure to introduce them. Today we are happy to have here Professor Bryan Brooks from Baylor University. Welcome. Professor Gerhard Lammel from Max Planck Institute for Chemistry and also from Recetox of Masarykovou Univerzitou. Thank you for joining us. And Professor Robert Barucki from INSERM Paris and Paris Descartes University. Welcome. My name is Kateřina Poláková. I will be moderator of this program, so let me tell you something about the program. At the beginning, we will have presentations of our speakers, and then we will follow with panel discussion. The important thing is that you can be part of it, so you can ask questions. Don't hesitate to ask. I'm sure our speakers will be happy to answer all your questions. And then you can enjoy 3D projection. It's a little surprise for you, and then we will follow with the informal part of the program with some folk music. But before we start, I would like to invite on stage Vice Rector for Research and Doctoral Studies of Masarykovou Univerzitou, Šárka Pospíšilová. Also Jana Klánová, the Director of Recetox of Masarykovou Univerzitou, and Pavel Jungwirth, the President of Czech Learned Society. And I have to borrow the microphone for a while. So, Professor Pospíšilová, let me come to you first. It's yours.
Thank you very much for the introduction, and it's my great pleasure to welcome you in this occasion and welcome in Brno. Masarykovou University is one of the organizers of this meeting, and I'm very happy that we have these three special guests who visited our university for a couple of days, and they will present the results of their research. I would like to emphasize that Masarykovou University is very much supporting both interdisciplinary research, and we will learn a lot about the different disciplines, as a Recetox Center is combining chemical sciences, biological sciences with mathematics, statistics, and on the other hand also with social science. And Masarykovou University also supports the way to sustainability, which is very important in these difficult times. So I don't want to speak too much, but I'm very pleased for that meeting, and once more welcome here in Brno, and thanks for coming, and enjoy the whole afternoon.
Thank you.
Good afternoon also from my side. I'm so happy to see you here. I see a lot of great colleagues from the Learned Society of the Czech Republic. I see very special guest. We have Dr. Grigar with us, and our generation who grew up on his show on TV. We always appreciate it, and in this special location, he is really dear guest to us, and I bet half of the audience came because of you, not because of the sustainability. I would like to thank people from all the faculties, because I see the representatives and colleague scientists from almost all faculties of Masarykovou University, some people from the rectorate office. We can tell that this is very cross-cutting panel discussion. We will probably touch upon many important topics, and I'm very happy to see people from across Masaryk University and also other institutes located in Brno, a lot of Learned Society members that are from the Academy of Science institutes located in Brno. And I'm especially happy to see so many students of Masaryk University. So thank you very much for coming, and I hope that you will enjoy the show.
Thank you very much.
Well, good afternoon. I have very little to say as a guy from Prague. Just that I'm very happy and grateful, particularly to Jana for organizing this event. This is an event co-organized by the Learned Society of the Czech Republic, and I stress it's the Learned Society of the Czech Republic, not Learned Society of Prague. And this is a clear demonstration that science goes way, way beyond the capital and is actually moving to Brno, and Brno is taking over, and I'm very happy to see that. That's all I want to say. Thank you very much, and yeah, let's have fun.
Thank you very much for the introduction. So I think we can start. So let me come to you first, Professor Brooks. We can start with your presentation. I hope it's ready. Yeah.
Why are we here? Is not a question that I will provide an answer. But I do hope that we think about things that are bigger than us, especially at the intersections of environment and health. I think about the Sustainable Development Goals as someone who's worked around the world in low and middle income countries as well as more developed regions. These are noble goals. We should try to reach these goals. We should also understand the connections between them, like the food, energy, and water nexus, which is a very important global megatrend. There are many things that are disconcerting happening in our world today, not more than just even a few hundred kilometers from here. But these megatrends will continue. Human societies depend upon them. At the same time, we're trying to meet the noble goals. We have great challenges. We now realize that pollution, especially in low and middle income regions, is a great and a growing global problem for people's health. At the same time, we're understanding the interconnections between biodiversity, ecosystem services, and human health in new and important ways. And recently, the IPBES, Environmental Assessment of Biodiversity and Ecosystem Services, has come with a stark warning that the diversity of species between species and ecosystems is declining now faster than any other time in human history. We have noble goals, we have important challenges. Instead of spending the rest of my time thinking about the work that I've done, I'll weave some of this in, but instead of this being a me presentation, the rest will be a we presentation. Because what I've been doing the last few years is working with scientists and engineers around the world across disciplines and among sectors to identify strategic research needs related to environmental quality. Many of these are at the actual specific intersections of environment and health. And global megatrends are influencing these interactions. We are concentrating people in cities unlike any other time in human history. We're increasing chemical production and consumption in these urban areas. We also are increasing the consumption of natural resources like food, energy, and water. This is becoming an urbanizing planet. We need to manage human exposures to chemicals in more sustainable ways. We think about Green New Deals, we think about all of the other challenges that we face. This is where most of the people will live in the future. This is where most of the people live right now around the world. We have to get our arms around urbanization. And we have to think about these connections between the natural world and human health in new ways. The One Health approach, as an example, is thinking about these inherent connections. And we see, according to the World Health Organization, that antibiotic resistance may, in fact, be, if not the, one of the greatest global health threats. And we know that there are environmental components that influence the development of antibiotic-resistant genes. Here's some work with some colleagues that's looking at the intersections of climate change and the discharge of antibiotic residues above certain thresholds can promote the development of antibiotic resistance. And under those climate change types of forecast and low flow conditions, red is not good because we're exceeding water thresholds of antibiotics that would start accelerating the development of antibiotic-resistant microorganisms. This is concerning when my colleagues with the pharmaceutical industries have told me to get my elective surgeries done in the next 15 to 20 years because the rate of antibiotic resistance development is outpacing the development of new lead antibiotics in many cases. Climate change intersects with all kinds of aspects. It's a global forcing factor related to this food, energy, water megatrend. The blue revolution, or aquaculture, is becoming increasingly important to feed the world. We have to grow food from the 239 animals, plants listed by the FAO to help meet food consumption demands. Just in low and middle income countries alone, we need a 200% increase in food production by 2050. We can do it. The challenge is right now it's estimated that 80% of the sewage developed and released in the world goes untreated. So we have reuse or recycling of raw sewage or even partially treated sewage. That is the basis for which people are growing food. Humans eat food. We're talking about interconnections between environment and human health. I'm pleased to be working with some of my colleagues at the University of South Bohemia thinking about aquaculture, urbanization, water resources, and developing low-cost approaches to be able to reclaim water for aquaculture production. Some of the work here by some of our colleagues recently published identifying pond systems may be low-cost opportunities to improve water prior to growing food for people. Other climate change forcing factors are harmful algal blooms, which are growing in magnitude, frequency, and duration around the world. These create situations which can decimate aquaculture operations, present important risks to people and the natural world. A few years ago, we asked, are harmful algal blooms becoming the greatest inland water quality threat to public health and ecosystems? The simple answer is, in some places, some cases, and sometimes, they already are. Inherent connections between environment and health. And with some funding from the National Institutes of Health and some of our colleagues, we're trying to understand these interactions and how climate change is influencing them. There's good news, there's tremendous opportunities for innovation as we engage these challenges. Green and sustainable chemistry and engineering, massive resource investments, discovery, innovation. Can we design a more sustainable world? I would encourage you, if you're not familiar with this concept, to check out the American Chemical Society's Green Chemistry Institute. People are going to make a lot of money advancing sustainability, realizing the Green New Deal. This is a key opportunity for science and engineering because just the principle for chemical products can be designed to preserve efficacy of function while reducing toxicity and other environmental hazards is inherently a public health approach. It's a preventative approach that can stimulate innovation and provide opportunities to reduce risks to the environment and health. We need to prepare people in these new areas at universities. We also need to prepare people that work at the interface of environment and health to improve the practice. We asked another simple question a few years ago with the Centers for Disease Control and Prevention in the United States. We partnered with our National Environmental Health Association, and for the first time since the early 1960s, we aim to understand the second largest part of the public health workforce in the United States. Similar exercises have not been performed around the world. What did we find? Well, I would point you to some of our publications. This is all available on the CDC's website. But the point is that people were overworked, understaffed, and the training and education needs are critical for the second largest part of the public health workforce in the United States after nursing. More importantly, 26% of the environmental health professionals working in health departments plan to retire in 5 years, but only 6% of the students in public health are concentrating their studies in environmental health, a backbone of public health. The backbone, I would argue, works at the interface of environment and health, and it always has. This is the foundation of public health. And oh, by the way, the biggest priorities for the workforce was retaining trained and skilled staff and recruiting qualified applicants. Robert, this was before COVID-19. When was that? This came out in 2019, 2020. And then COVID-19 happened, and it's really stressed an already overworked and understaffed workforce. Here's an assessment by the National Environmental Health Association of just the United States. Yet we see the same trends. We see the same pressures that's put on the people that are standing between environmental stress, vectors of disease, and our positive health outcomes. So I would submit that strategic research and education engagement is absolutely necessary at the intersections of the environment and health in your country and my country, around the world. Think about the regions where the infrastructure is not as well developed as Europe, as other parts of the West. And these global megatrends will continue. Why are we here? I hope that we're here to try to work together, to think together, to engage some of the greatest challenges that we are facing as a global community, because we need strategic preparedness. And we need to prepare the workforce in prevention to manage future health risks associated with environmental exposures. Thank you very much.
Thank you very much for the first presentation. Do you want to add something? Our other speakers, would you like to comment on that right now?
Maybe I can. Just a question for you, Bryan. This was brilliant, by the way. The COVID has been, a major influence here. Are there any positive outcomes of this COVID crisis concerning the environment?
In the United States, what I continue to hear from my colleagues, and I'm funded by CDC, and we work in different types of aspects with health departments and, across the spectrum, is that it has forced different parts of public health practice to connect and to cooperate in ways that perhaps has not occurred in the past. Out of necessity, you're pulling staff from all of these areas to be involved with contact tracing and rollout of different types of vaccination facilities and. And so I think, if anything, on the one hand, COVID has shown the light on the disparities, really the fractures in the system, but on the other hand, it's forced people to work together perhaps that have not always cooperated as closely as they could. Thank you.
Thank you. And now we will follow with presentation of Professor Lamel. So it's yours.
Thank you. Good afternoon, everybody. I'd like to draw your attention now to the environment around us, to even the Earth system. I could also talk about the planet A. And before I start to maybe compress the news from the environment in a few minutes for you, I'd like to emphasize our perception now, which is that mankind has actually also a geological force developed over the decades, recent decades. And as you see here, we have changed not only the atmosphere, we have also changed the mass flows on this planet. Also very subtle biogeochemical cycles have been completely changed, some of them, nitrogen for instance. And these impacts will last very long. For instance, climate scientists tell us that it will take 50,000 years in order to relax back to the undisturbed climate. So the terminology Anthropocene, this term was coined by Paul Crutzen, the one who explained the ozone chemistry and the stratospheric ozone chemistry for us in 2002. The news from I start with the news from the atmosphere. There were bad news from the climate drivers. Never before that much CO2 had been emitted than last year, as the International Environment Agency, Energy Agency told us a few weeks ago. And for methane, the same. And for methane, it is also very it's unclear why it has accelerated. Not only last year, but it's unclear why it started to accelerate like 10 years ago. So we do not know where it comes from. I mean, come back to that point. Stratospheric ozone, you know the success story from the Montreal Protocol, which was started in 1987. We have tremendous success in mitigating the precursors for the harmful radicals in the stratosphere. You see this steep decline, and corresponding to it, a delayed, very slow, much slower decline in the precursors, in these radicals which are destroying the ozone, because of the lifetime of these substances, which we have to mitigate. And the expectancy now was of the World Meteorological Organization in 2018, as shown here, that the ozone hole would nicely recover by 2040, 2050 or so to the pre-ozone hole state. But then in 2019, a major leak was detected in China, actually. Several of these precursors have been emitted in non-compliance with the Montreal Protocol. And the good news, this is the very good news of this year, of last year, is that this leak has now been closed again, and we are back to the trajectory to recover, to heal the ozone hole. But there will be some feedback from climate, from the climate side, because of the global warming at the ground means that the ozone chemistry is accelerated in the stratosphere, and so we expect a little bit of a delay nevertheless. In the air we breathe, the news is that with the methane going up, also the ozone goes up, which is natural chemistry in the atmosphere. And that has reached levels which reduce the plant growth of our forests, of our crops, at least in the northern hemisphere, since a few years. And ozone is a powerful greenhouse gas itself. Then we have the precursors of the aerosols, nitrogen oxides, which we have now brought to 4 times the pre-industrial level globally, and ammonia, which we have also driven by far from the agriculture, and together with hydrocarbons from industries and so on, we are producing a lot of air pollution, which is growing. And we have been producing acidification and eutrophication, as you're probably aware of, since a number of decades yet, and even in Europe, where a lot of mitigation has been put in place successfully, even in Europe, 2/3 of the ecosystems by area receive too much of nutrients. We have also here a feedback from climate. There will be more fires in a warmer climate, and we expect more of these precursors of the aerosols, plus we expect more of long-lived chemicals which are emitted from fires too. I mentioned here the dioxins and the PAHs. And only a few weeks ago, the new the first global emission data have been released by the European Commission until the year 2018, and there the bad news was that 2018 was the year with the highest emissions of PAHs and dioxins, even though this is decades after mitigation measures in many regions of the world ongoing since a few decades. Pesticides, biocides, and some flame retardants, which are intentionally introduced into the environment, have been declining because of bans in the 1980s, and they are now slowly fading away, but we know that under global distribution, they are redistributing. And these trends are also leveling off. This is also a news from last year. At least in some regions, these trends are leveling off, means that there are secondary sources where old inventory is coming up again. Yeah, substances may leak from production processes and from the life cycle of goods, that is obvious. And many substance classes accordingly are considered to be chemicals of emerging concern, means we will have more problems eventually in the future with these substances, not hidden so far and not visible so far. For instance, more than 3,000 substances have been considered as candidates to be of emerging Arctic concern, and each year a few dozens of those are actually kind of arriving, first time observed in the Arctic. First time we also saw that polar waterborne substances are arriving in the Arctic, which had been not expected, but now we understand that sea spray is a source for pollutants to the atmosphere if the surface waters have received, by washout from rain, for instance, waterborne substances, which otherwise would never make it into the atmosphere. So we also expect a number of pharmaceutical substances and other substances in the Arctic, for instance, which we had not expected previously. Okay, also here we have some feedback from climate change, namely that mobilization is ongoing. Earlier stocks from the past are released. For instance, glaciers are smelting, sea ice is melting, and also we do expect that due to chemical equilibrium, the ocean surface waters do return the old pesticides into the atmosphere currently. I skipped this because we have anyway covered pharmaceuticals, I think, in the previous talk. This is the first, it's about the first ever effort to have a global overview of pollution by pharmaceuticals, published a few weeks ago. So, which impacts are actually following from these drivers, from this pressure to the environment? Well, you know, of course, that the Earth is on a fast warming track. The expectation is that we would reach 1.5 degree warmer atmosphere in 2040 as compared to the beginning of the industrial evolution. And given the current commitments to mitigate gases, and we do see that extreme weather and weather events are becoming more frequent. And we also see, like the thunderstorm, for instance, like the tornado we saw here in this region last year. Then to the nutrients and the aerosols, for many regions it is diagnosed that it's too much for the ecosystems. So we do get damages to the ecosystems. for the long-lived substances, we do know that if the substances are endocrine, disrupting pharmaceuticals or some other chemicals which are bioaccumulative, that you can have adverse effects, or you do have adverse effects in marine wildlife, in terrestrial wildlife, even at the extremely low concentrations after dilution globally. My hypothesis is that the effects of global wildlife chronic exposure to so many biologically active substances cannot be quantified nor localized, neither individually nor in the mix in the future, because of the diversity being so big and the pace being so fast. We see that substances are returning from melting ice, I said that, and from the oceans. We also expect that the plastic pollution in the oceans, but also even in the atmosphere, also in sediments and in the hydrosphere in general, might provide a vector which has not been there before in order to accelerate the bioaccumulation, biomagnification in the food webs. Ozone will be increasing according to our mitigation measures. So if we are mitigating fossil fuel usage much more than we did in the past, then it will not. But for now, we do expect that there will be more of elevated tropospheric ozone around, and the vegetation will accordingly suffer. Global warming might be accelerated because of internal positive feedbacks. So permafrost is maybe melting faster, and that could explain part of the unresolved reason for the elevated methane, for instance. Okay, where are we going? Of course, it makes sense to really consider what is the carrying capacity eventually of this globe. There might be some boundaries, right? And one of the concepts which was suggested a number of years ago is the concept of planetary boundaries. That means there is some pressure beyond which we cannot safely operate, because we are not safe for abrupt or irreversible changes. And that has been quantified for a number of problems, including the climate problem, for instance, which brought us the 1.5 and 2 degree suggestions to stay within, right? And a few weeks ago, it has been published also for chemical pollution, the assessment that we have exceeded the safe operating space, also for chemical pollution. Well, obviously, in order to cope with these problems, we have to recognize the long-term implications and the dynamics of the Earth system. That successfully was done with regard to the ozone layer. The dimension in temporal as well as in spatial dimensions really requests us to work together internationally, globally. And on our agenda, high up, is now the decarbonization. For obvious reasons, the IPCC only a few weeks ago stated that now is the now or never option for the 1.5 degree warming limit, and there is no option to wait any longer. I would like to leave for the discussion here at least these lessons, namely that there is always the possibility that there are extra leaks or extra delays of because of non-compliance, even after the agreement has been possible, has been established. And in order to avoid bad surprises in the future, we should really move to more prevention in our strategy. And in this regard, we should probably talk about the green chemistry initiatives which are on the table. Thank you for your attention.
Thank you very much. Any reaction right now? Okay, so we can proceed. So I would like to ask Professor Baruki for his presentation.
Thank you. Thank you very much. Waiting for the... Okay. So I will be speaking about the relationship between environment and health, and human health. This will be the focus of my... You will hear some things that are related to what you have already heard, but the focus will be on the impacts on human health. And I call it the 3 C's that are, the focus of our interest: climate, cities, and chemicals. But there is also one S, which is the social aspect, and I will get back to this at the end of my talk. This is not something... I am an MD, and I am molecular toxicology in my lab, and I will not speak about what I'm actually doing in my lab. I will be speaking about a program, an EU-funded program called HERA. HERA means Health and Environment Research Agenda. It's actually the commission that asked us, we were 23 partners, they asked us to provide the commission with what do we know already and what we do not know, and what do we need, what the stakeholders tell us that we need in this field, linking environment, climate, and health. So we were 23 partners and tried to provide the commission with suggestion where we should do more research in the future and what do we know currently. And to organize the research, there are 3 main components. The first one is very broad global issues like climate change, biodiversity loss, major issue, water, that on the globe. And of course, we have to reduce all these threats and insults on our planet and on our health. So this is the global aspect. The second point, the second component is more local aspect, problem-based. For example, how do we deal with cities? How do we deal with the workplace, the place where we work? How we are exposed to so many different things in the workplace. How do we deal with that? So these are problem-based: cities, rural areas, workforce, etc., workplace, etc. And the third aspect is the stressors themselves: chemicals, physical stressors, biological stressors. How do we deal with those? In each case, we have developed some suggestion to do more research. You can find them on our site, heraresearcheu.eu. But in order to go further, the fourth component, the fourth aspect is that for each of these cases, we have to improve our capacity to identify and quantify the health impact of a certain stressors, for example. What is the health impact of that chemical or air pollution or climate change, etc.? This is really important because it's not so easy. This is really something that is not easy and difficult. It's also important because once you identify and quantify the health impact, you can also quantify the economical aspect of it. The costs, the economical cost of that stressor, of that issue. And that, politicians are interested in what it costs every day. So it's really important for prevention, I think, to identify this. The fifth aspect is that in order to do the research, we need infrastructure. We need to build solid, robust, and sustainable infrastructure to assay chemicals, as is done here in Talks, or to provide, store data, modelize things, store samples, etc., etc. And finally, maybe for some, maybe more importantly, what are the consequences on society? What are the political, the ethical, the economical, the educational consequences on society to deal with this? I mean, what kind of research do we need to do to be doing? Because in many cases, we know what to do, but the implementation of our programs doesn't go well. So we have to do research on how to best implement some decisions. You know, we want people not to smoke anymore, but why are we still with like 18 or 20% of the people that still smoke? I mean, how to implement a decision? This is something that is really extremely relevant. So this is the big vision that Hera proposed, and in each case, I will not, of course, develop everything, but I will focus on some aspects. Let's take climate change and health, the impact of climate change and health. We know already a few things, but there are issues that still need to be further developed. There are different impacts of climate change and health that you could see up here. And in many of the cases, it's a problem of increased or changes in exposure. For example, we mentioned air quality. There is an issue within climate change modifying air quality, and therefore we are more exposed. The heat, of course, you have all heard. I mean, when some summers are so hot now that we have major issues on health, on dehydration and people death. We have water quality, obviously. We also have, for example, infections related to mosquitoes or to other vectors that are related to infection, and we are certainly expect an increase in infection related to climate health. And obviously the social factor, when you have extreme weather, you have floods, people suffer from this. There's what we call post-traumatic syndromes related to that, and therefore mental health is a major target of climate change and its impact. So all these are exposures, and what is really bothering us for a while is that the people that work on climate change are different usually from the people that work on other environmental issues, and this should not be the case. This is all part of what we call the exposome, which is all the exposures that we have to undergo during all our life. When I mean exposure to chemical, to physical agent, biological, but also to social factor. Climate change should be integrated in that big picture of the exposome. And many of you know what happened with the genome projects and how much we have learned by identifying the genomes. We should now do the effort to identify better and characterize better the exposome, including the effects of climate change, to work to better understand what's happening. Cities are obviously, this has already been alluded to by Bryan, and therefore many of us live in cities. There are major issues in cities: air pollution, light pollution, really something really important, noise in cities. All this is happening to us. Also, this is also related to the aging of the population. The population is aging too. So there are really important projects that should be done on how to organize the cities in blocks, for example. This is what you can see here is a picture of where it could be organized in blocks, maybe preventing cars of going into certain parts of the city, allowing them to go in other parts, and using bikes, etc. I mean, there is research and there is need for maybe more support on how should we organize cities so that we could live well, have green areas, water areas in cities, and also suffer well from the consequences of living in cities. Chemicals is important. You can see the iceberg here. Let's say we have 100,000 chemicals on the market nowadays. The iceberg shows, and this is from the chemical strategy for sustainability of the European Commission. I mean, they didn't invent that. And the EEA did it. So the tip of the iceberg, 500 out of 100,000, 0.5% are chemicals for which we know a lot about exposure and toxicity. I work on dioxin, other work, we know a lot on dioxin, and this is part of the 500. However, then you have 10,000 for which we know something. For example, is it carcinogenic or not, and nothing much more. 20,000 for which we know a little bit, and 70,000 for which we know nothing. So even in the field of chemicals, exposure to chemicals, there's still a lot to do. However, we will not do with the 99,000 chemicals that remain the same kind of job that we are doing on the 500 that we have already done. Of course, we will use what we have done on those big 500 to learn more and model and predict what could happen with the others. And this is why structures and labs that can do chemical analysis, that can do modeling, that can do, kinetics of chemicals are so important. And we have been so privileged here to visit Resetox and see what's going on in there. I would like to highlight one aspect also, because this is so critical, and these are recent findings on human health, the effect of developmental exposure. All the exposure that happens during the fetal period or the very early life. The WHO calls it the 1,000 days, first days, but mostly during the fetal period. And I'm talking about all kinds of exposure. If, for example, chemicals, but also diet, drugs, alcohol, but also, social, psychological stress during that period. This can impact the risk of increased health hazard later in life. It increases the risk of having, for example, diabetes later in our life, or obesity, or some cancers. I mean, there's more and more evidence for this, and this is something really important, and maybe we should focus the prevention on these initial period of the year of our life, and make sure that there are not, consequences that will not appear immediately. The child is born and is doing really well, but that may appear later in life as an increased risk for all kinds of exposure. So there are mechanisms that we start to understand. I would like to highlight epigenetic mechanism. I mean, any kind of influence on the expression of genes, not altering the sequence of the gene. This is not genetics. This is really influencing the expression of gene, but that is inheritable from one cell to the other. This is why something that can happen to you during your fetal period may have epigenetic effects that would show up much later in your life by increasing risk. So we have to be really careful with this. And the last point is the S. We've seen chemicals, we've seen cities, we've seen climate, and the last one, the social aspect. I mean, and here we have really reflected a lot on that, and many people promote what is called transformational change. We will not be able to live in the next future the same way as we live now, because of the climate, because of the environment, because of the planetary boundaries that were mentioned a little bit earlier. We have to adapt, we have to mitigate and adapt in order for our societies to be more sustainable. So we have made a number of suggestions, for example, among which preparedness. We should be much better prepared for crisis. We are not well prepared for crisis, we have shown that. I mean, history has shown that lately. We should be much better prepared. There are all kinds of... We should also better communicate, and the way we communicate on crisis is extremely important, and we should do it in a more maybe organized and scientific way. Society is changing, for example, by digital transformation of our societies, and we have seen that. And the cartoon here on digital transformation shows you that it's not the CEO of a company that did it. It's COVID that suddenly, in a matter of days or weeks, suddenly increased the digital transformation, and this should increase even more. We should also be aware that we have some ethical and philosophical responsibilities toward the future generations. Whatever we are doing now will have an influence on what our children and grandchildren will experience later. So there is an ethical, maybe something that could go into law, I mean, about our responsibility towards the future generation. And of course, there are multiple of other societal effects that can be mentioned, as well as political impact. So what I'm showing in the lower part is that, people and sociologists like to give some, name these generations. You have, of course, the baby boomers. We all know the Generation X, millennials, Generation Z, etc. So suggestion is that the next generation will be so much influenced by climate change and environmental change. Maybe we should call it CC or CCC, because I have 3 Cs actually, but climate crisis at least would be important. So with this, I would like to thank you.
Thank you very much. Okay, so we can start with the panel discussion. It's pretty obvious that if we want to be healthy, we need to have healthy environment. We need to have healthy planet. According to IPCC report, which was mentioned in one of the presentations and which was released this month, we have to act now. like really now, to avoid climate disaster. So do you all agree it's now or never? And what is the priority number one from your perspective?
Yeah, thank you very much for this question. I think we really have to accept that we cannot work through the whole iceberg because of the need to prioritize. And so luckily, many of the problems, even if we do not completely understand them by now, I mentioned, for instance, the many individual toxins in our air, which have still mostly the main source, which is fossil fuel usage. Luckily, we do not need to wait until we have understood all these mechanisms. We can simply rely on the fact that fossil fuel usage, which makes us all this climate problem, will also be very, very effective in removing other problems. So I fully would like to support that we need to prioritize fossil fuel mitigations, and then we will solve many, many problems. And science can, as a scientist, of course, I would like to continue researching, but science can do research while we have to implement all these measures. So there should not be longer waiting until science has answered the last questions. That is my plea.
If I may, is this working? Not working.
Okay. Okay. So you have to share.
Okay, I'll share. No problem. We like sharing in science, you know. So yeah, I think clearly, yeah, fossil fuel is an issue, but we are facing several problems at the same time. We are not facing a single problem. I mean, acting on climate is certainly a necessity, and I agree with you. We should start now, and we should start certainly with fossil fuel, because there are many cases where we have so-called co-benefits, in the sense that if we work on, you know, fossil fuel, we have several other benefits. You know, the air quality in a city would be related. But there are many problems. I mean, for example, diets is a problem. We can also have some influence on diet. Chemicals in general, we should also work on them. And I think we don't really have too much time. We should really try to work on different things together. It's not necessarily extremely difficult. Sometimes you have to compromise and find, you know, put priorities. But in many cases, we should go ahead and understand that there are many different issues, and that we should really try to work on them. And in some cases, there are very good, you know, we are lucky and we have co-benefits. If we eat less meat, for example, it's good for the environment in many respects, you know, the air and the quality of water, etc. It's good for us. As a doctor, I mean, you say eating less meat is good. Cardiovascular disease, colon cancer would decrease. So here you are doing something really nice at different levels.
It's a win-win situation.
Yeah, I agree with the comments made by my colleagues. But I think that we really need to recognize the importance of communication, and that we've been experiencing weaponization of disinformation. And so, but this is a brilliant strategy, isn't it? By someone who aims to do something that is against the evidence. As we move forward with science and engineering, we hope that we're contributing to evidence-based decision-making. Yet we see illustrated during the COVID pandemic that basic public health measures that have been affected for well over 120 years because of the weaponization of disinformation has actually led to inactivity. And people, maybe you know, I know for sure, in the United States that have died because of this disinformation. And so I think this is very important. I think we need to be engaging these environment and health interfaces. We need to be working with health communicators, health educators as well, to basically restore our faith and our trust in science in the face of such disinformation campaigns.
Professor Baruki, you have your advice how to fight fake news.
Yes, of course you have to, and what this reflects, I mean, I think the communication aspect is really important, because it's not enough to be a good scientist or to do some good science. I mean, it's clearly not enough, because we have an urgent problem here, is that the citizens should understand and follow. I mean, and understand what we are saying, and we should understand what they are saying and thinking. So the communication is in both ways, actually, and it's really very critical. So yes, I think this is really at a top priority to really listen to what the society is telling us. And the second point, and this is why maybe I didn't mention it, but we highlighted also the importance of education at all levels, not only during school. I mean, education during all life. You know, hopefully this is what we're doing now.
And what do you miss the most in public debate? Because these issues influence everyone, but not everyone is able to comprehend what is really going on.
I think people do not understand because there is something really important in science, which is uncertainties in science. I mean, we work with uncertainties all the time. It's part of our job, I mean, to live with uncertainties. And what happened with the COVID is that because the scientists were working at the same time when the people were listening to the TV and hearing what's happening, and they did not understand why this doctor was saying something and the other doctor was saying something different. In our field, you know, if Bryan says something and I don't agree, this is, you know, this is the regular thing. And that's how progress is made, really. But to the public, it's not. So when we say education, I mean, maybe the first thing is to make people understand what is the scientific method. I mean, people tended to forget that. It's in Descartes, and it's la méthode scientifique, the scientific method. It's old, but still, I mean, I think we did not provide the right, you know, information to the people that this is very important, and they should follow us.
Would you like to comment on that? What do you miss in a public debate? Professor
I think there is also a standard for journalism that to make sure that the tradition how journalism was developing in the last century is maintained, and I see some erosion there. Which cannot be, I mean, it's difficult for us scientists to combat that trend.
Professor Brooks?
Very simply, I would just say collegiality, right? Understanding, not talking at people, but listening to them. Right? Yeah. I think this is goodwill.
This will be the crucial step.
This will be the crucial step to develop trust. To understand the differences and try to work toward reasonable and meaningful solutions.
You already mentioned that the big issue is chemical pollution. We are using way too many chemicals every day, and we are producing new ones. According to the paper published this January in journal Environmental Science and Technology, which was also mentioned in one of the presentations, the chemical pollution has already passed the safe limit for humanity. So that sounds really scary. So what has to be done about it?
Well, you know, I won't comment on the specific paper. I'm familiar with the paper, having
because
been
you're
involved
also
with the
editor-in-chief of...
well, of the companion journal, and have been working with that journal as well. But the key is this. Look, we're not going to develop tomorrow, next year, a decade from now, maybe 2 decades from now, the types of Western management systems that focus on really effective prevention and interventions like we would hope all around the world. This is a big challenge. I know we have in the SDGs, for example, really noble goals, but this is where I think the strategic investment in broader aspects of green and sustainable chemistry and engineering become really important opportunities. Can we essentially stimulate innovation? Can we think about alternative supply chains? 90% or so of the chemicals in commerce come from petrochemical origin. Where are our feedstocks coming from over the next century? Where do we need to think about the opportunities to reduce the environmental impacts of various types of chemical exposures? And I think this is where truly we have tremendous opportunities, and people are going to make a lot of money, okay, in moving some of the sustainability sciences, focusing on robust chemistry, engineering, and interface with human health along the way.
Professor Baruki would like to comment on that.
Yes, I think the first thing is that there's usually in the public sometimes chemicals are associated with toxicity. I mean, I have seen that a number of times. Whereas in fact, we could argue that chemistry is life, chemistry is drugs that help saving us, etc., etc. And but for some reason, it's really has been associated with like doing some people say I don't want a chemical world, which is doesn't make any sense. So we have to explain that. I don't think we should stop either using or maybe producing chemical, but we should increase our knowledge about how to make the safest chemicals. I think you mentioned it, safe by design or sustainable design. This is where we really should put the effort to how to make sure that we are producing chemicals that are safe. And in France, for example, there is a big debate between people who are for the precautionary principle, that should be we should be very precautionary, and I'm in favor of the precautionary principle, but sometimes people oppose to be precautious with being less innovative. This is not the case. You can be extremely innovative and being precautious, because if you are really innovative, you can innovate on how to produce chemicals that have the least toxicity possible, and this would be great.
Mm-hmm. Professor Lamel, I would like to hear your comment too, because the study was mentioned in your presentation.
Yeah, I would like to come back to what we said with regard to these models predicting chemicals properties in safe design. We did this a couple of years ago. We started to do that, but not good enough. So we got bad lessons in the environment. So there is really a need to more invest into these models. These are by far not what how good we could do it, and in order to prevent chemicals which we do not want to have released into the environment. This is not a big thing. It can be done, but it has never been really emphasized. It was started as an activity to keep concerns low, but we do know we have to be much better in that discipline, I think.
Pollution is responsible for millions of premature deaths every year. It was in presentation of Professor Brooks. It's a well-known fact that it's linked to many diseases like cancer, respiratory diseases, cardiovascular diseases. But what are the less known effects of the pollution, and what impacts we don't see now, but we might see them in the future? You've been already talk about it, but let's concentrate on this topic a little bit more.
I think, to be honest, I think pollution has effects on many, many different diseases, but some are more obvious. I mean, you take, for example, air pollution has been quite studied in epidemiological study because we know how to measure, basically, air pollution, and we know how to correlate this with an effect. It's much more difficult, for example, to measure in blood some pollutants. We do it. I mean, this is done here in Brno at Resetox. But still, there are many that we do not do, and many that we should learn more. So the correlation between these exposure and disease is more difficult sometimes to appreciate. But the more you look at the literature, the more you find impacts of pollution on a large kind of disease. I have written an editorial recently on liver disease and pollution. I mean, non-alcoholic liver steatohepatitis, which is a major problem. I mean, having, it's a major, it's not only alcohol, there are many other pollutants, including air pollution and other chemicals that, do this. So, and kidney disease are also, things that we should look on. Immune disease, I mean, we know a little bit about those, but we are now seeing more and more impacts on immune diseases, and therefore, the more it has, and pollution has a global impact on many diseases. How much for each disease is difficult to answer. It's important. This is what I call the health impact assessment. It's important to address this. For example, we know that endocrine disruptor costs 150 billion per year for the EU, maybe more, and maybe more in the United States. So, but we still have to learn. But many, many diseases are targeted.
Well, I certainly agree, and think about some of our recent work with our collaborator examining some of the more potent liver toxins produced by harmful algal blooms, and Think about some of the drinking water treatment and lack thereof that may increase the likelihood of non-alcohol related liver disease in the future. But what I like to mention is that this is a challenge. This is complex. And that is why I'm so impressed by, well, really, why, frankly, the living lab here in Brno. And this is brilliant, because the social determinants of health need to also be understood within the studies of environment and health. And I think that's really what's being engaged here, because the subtlety of the effects oftentimes are magnified, you know, in fence-line communities and people of color, and so many of these examples that are so well documented in the literature, but we really need to think about the broader social determinants as really has been happening here at these intersections of environment and health.
We are talking about the future, and the future is going to be urban. It was already mentioned, more and more people are living in the cities, and by 2050, 70% of population will live in urban areas. So what the future life in the cities will look like if we don't take enough action, speaking of public health?
Well, I'll start. Look, the reality is there are tremendous opportunities with this megatrend of demographic transition to cities and population growth. So the challenge that I put forward is clearly when we're not managing human activities, the use of food and energy and water, because the connections among these essential resources are becoming more and more intrinsically entwined, specifically at the urban area. But how do we actually manage the waste streams from the human activities, whether it be atmospheric or solid waste, municipal sewage? I mean, how do we recover resources that have normally been just discarded in waste streams? Resource recovery is critically important in the future. That also gives us opportunities to reduce exposures. We need to probably grow up, not necessarily out. We need to think about the way that we manage waste to perhaps be more decentralized and localized. We need to think about water recycling and water reuse. I could go on and on, but the point is that the idea of smart cities is not just Internet of Things and some of the things that perhaps we've read about, but I think it's actually really looking for the opportunities to fuel the innovation as we think about the interconnectedness of resource use and the waste streams that emanate from the cities in which we increasingly live.
Any reaction?
I agree with this, but let me add one thing. I mean, it's all interconnected with medicine in particular. Why is it good to have green areas in cities? Probably the air quality will become a little bit better, but it encourages people to do exercise, to move, I mean, to walk and to bike, etc. And I think exercising enough now is considered as one of the major, public health prevention, approach to many chronic diseases. So there is a real interaction between what you do in your environment, how you manage the cities, and what we are learning in medicine about what is a good prevention. This is just to take an example.
Professor Almo, would you like to comment on that?
As an environmental chemist, I cannot really comment on that question. But I have a question. If 70% live in cities, did we also then concentrate all the mass flows into these 70%, or have we then exported the disposal and the leaks of our mass flows into the rural and remote environment? Or are there concepts which are comprehensive and are integrating into the city?
So can you give me like a concrete examples of cities that are prepared for future cities that are really progressive, or you can just mention specific urban projects that are promising, if there are any?
There is a city in Finland that I'm forgetting the name right now. I used to know the name, that has done really extremely well. It was not a great city, it's not a big city, but they have planned, you know, everything from scratch. I mean, how people should move in the city, how to organize the buildings, etc., so that they have a really nice, very environmentally friendly cities. I know a lot what's happening. There are many European projects on cities. I mean, and some of them, I know people in Barcelona that are really very good at that, and they have planned, you know, the picture that I showed was from them. I mean, how to organize blocks so that part of the block cars would not go into those parts, and people are encouraged to either walk or cycle. Where to put green areas in the city. I mean, there is a very famous picture from Seoul in Korea where they had highway in the middle of the cities, you know, like you can have in some cities, highway really in the middle, several highways, you know, intersecting, and they just decided to change this to put some water area, and this changed completely so there are initiatives, there are possibilities. I mean, the environment is not only the problem, it's sometimes the solution for many of these things. But there are also some political problems. For example, you say many people will go now live in the cities. After the COVID, we have seen a small trend to get out of the city and to a certain extent, maybe for those who can. But I think globally the trend is going this. But there are issues with all those areas that are, you know, losing population. They are losing their doctors. They are losing, you know, their business. They are losing. So there is a political issue here that comes and may complicate all this evolution.
Professor Brooks, are there any projects in your mind you would like to mention?
Well, I think I'd like to take this in a little bit of a different direction and highlight the importance of ecosystem services related to mitigating disaster risks. You know, I live in a state in the U.S. along the Gulf Coast. Think about even like the United Nations disaster risk reduction types of efforts. I mean, ecosystem services provided by fringing vegetation, mangroves, wetland systems can be really, really important in terms of mitigating disaster risks. And so as we move forward, in some ways, the commonality with what we see with COVID as basically a global disruptor of systems is also experienced when we think about making cities more sustainable. City resiliency scorecard, for example, developed by the United Nations, is perhaps a useful tool if you're not familiar to be able to think about your city where you live. And certainly elements of that is happening here in Brno, which is really exciting.
There need to be political will to change things, because the scientists have been calling for action for a very long time, but the process is still slow. So tell me, from your experience, what is working on policymakers and how to make them listen to you, how to make them act?
Do I have to answer?
Yes.
Okay, so I'm in the
Please.
United States, and I live in Texas, and we have pendulums that swing just like everyone else from a political standpoint. But it's my understanding that more people live in solar or work in solar and wind in Texas than gas and oil now. Sustainability done well can be profitable. And so I think we have to look for these win-win situations. And so, you know, even our governor, which is in one party perhaps that is oftentimes characterized as not necessarily environmentally progressive or friendly, has publicly stated that he wants Texas to be the epicenter of clean energy and green energy, right? Sustainable energy. So again, sustainability done well can be profitable. I think this is a key consideration.
Okay.
I guess the climate debate has shown us that it is really moving politicians if they see that the majority of the population is asking for action. As you could see a few years ago, when those kids who preferred to go for demonstrations on Fridays rather than attend the schools put pressure on politicians, and only repeating what scientists had said decades ago to the same topic. So then something happened easier than science did that manage to bring politicians into action. So.
Yeah, I totally agree. I think it's a citizen, efforts. That's it's a social problem. I mean, so everybody should do it. So that could put in. But as you say in the US, the economy is stupid. It's the economy stupid. That's always, and it's not. I think when you speak to people in ministries, many of them are quite convinced. Actually, I mean, they support us in many respects. Speak to people in even in industry. Some of them are really very, very open, but it's really difficult to change things because they believe that they are going on in areas where they don't know where they're going. Maybe the economy will be not sustainable with these changes. But I'm convinced that we have to, maybe a big crisis. What makes things change a lot and quickly are big crises. But we shouldn't hope for that. But on the other hand, it may happen,
But here in Europe, we are lucky that we have now the Green Deal. So we made the politicians did go for it. So I think we are lucky that we have now the point where politicians are ready to go.
Yeah, but now we are facing another crisis after the pandemic of COVID-19. We are witnessing this horrifying, brutal war in Ukraine. So how do you think it's going to affect all these goals like Green Deal and other goals we have to reach?
Yeah, I can only hope that politics is sticking to the agenda we agreed upon. Yeah.
I cannot speculate really here because it's really difficult to say what can happen. I mean, of course, if the priority becomes different, the geopolitical priority, then you may think that some other things will go below, change the priorities for the environmental aspect. I hope not. But on the other hand, part of this, horror that's happening is leading to problems in energy. And this is maybe an opportunity to shift completely to a clean energy. So crisis can be opportunities too, and hopefully this will happen. But so difficult to speculate.
Let's hope so. Okay. That's what I wanted to.
I have to comment on this.
Okay.
In fact, I have two comments.
Maybe if you can wait for the microphone. Okay.
Thank you. Thanks. I have two comments, and one really goes back to the now or never. To start action or to go on with action to keep the global warming under 1.5 degrees of centigrade. This is very difficult now. Let's take this country, which is 100% dependent on the Russian gas and, I don't know, the large share of Russian oil as well. Now, the very serious discussion is now going on here to prolong working the coal power plants for producing electricity. And so that certainly will shift, at least in the Central and Eastern Europe, these goals, I don't know how many years, but certainly it shifted to a longer time. So that is, I think, inevitable in certain parts of Europe. Okay, and if I have the microphone, I have another comment, and that is a question was here whether we have any positive something that we can learn from the COVID-19 pandemics. And I think we didn't mention, and you also didn't mention, as far as I get it, that there is one positive outcome of this, and that is that a completely new type of vaccines was not only developed, but it was very fast produced. And in addition to it, because the COVID-19 pandemics was really a global pandemic, we have enough data now, a large data, that shows us that these are safe vaccines and that we can really use them in the future. Perhaps we are now ready and prepared to use them in the future. We know that they are safe, we know how to produce them, we know the principles of the completely new types of vaccines. So in spite of the death casualties and all that, this is, I think, a positive outcome.
Thank you. Thank you very much. So this is the only one that's working? Sorry. So, any reaction? Who would like to comment on
I
it?
would just say that I don't understand perhaps the energy situation in the Czech Republic as much as you do, but I would agree that there are positive outcomes that we can think about from a global pandemic. You know, I mentioned in response to your question that it's forced people to work together. I'll give you another example. We have developed surveillance and monitoring programs for RNA associated with COVID. Variants of concern in wastewater. We work with private, public, government entities to identify early warning signals, to identify locations where targeted public health activities could occur, and when healthcare resources should be prioritized. I think this is a network of not new, but rapidly expanding public health infrastructure that is occurring around the world and will also be very useful for other types of viruses. I've used it to track drugs of abuse and other types of health indicators for years. But this is just one example where it also forced people to work together, and it's been successful because you had the engineers and you had the docs and you had the EPIs and you had the virologists and you know, all these folks coming together to identify lead indicator surveillance systems to support decision making and reduce, quite frankly, some of the economic burdens.
Let me add a comment on the RNA vaccine. Yes, I totally agree with you. This is certainly a major outcome of this crisis. However, you know, I work in a pediatrics hospital. We have genetic diseases, and these companies that have developed the RNA vaccine also were initially trying to develop RNA vectors for curing genetic diseases, and actually the clinical studies have been going on this, and the safety was pretty good. I mean, so there were maybe 10 years of experience in saying that in certain genetic diseases this works and the safety seems okay, which also helped. Of course, suddenly, you know, they shifted then to the vaccines, and some of them were also working on cancer also with this, but then they shifted to vaccine, and it was such a fantastic. But crises do that, you know, suddenly, you know, allowing some major, and the science that we are doing, the science level which we are allows this kind of development.
Thank you. So, are there any other questions from the audience? Okay, so let's please wait for the microphone. We have another one. So, okay. Thank you. Thank you.
Thank you. I wanted perhaps to come back to this conflict, coal, gas, clean energy, green, and so on, in perhaps a more abstract way. So you mentioned a lot about how to clean the air and how to have less diseases and so on, some global strategies, and that I would call optimization of efforts, right? But we all are part of the social network, business is important, or maybe the most important, right? And my question is whether there are efforts to somehow study this more equilibrium situation, right? Okay, so you seem to, or we seem to understand better what to do to globally improve things, right? But then the situation is that we are not globally cooperating, right? So, so my question is that if there are some studies of the actual situation, assuming the greedy behavior of some players, and we know basically taking into account our Earth situation, right? So we can somehow predict the parameters of the global players and their utilities and so on. So assuming that they somehow which actually that's somehow that's happening probably, that the players follow their own interests. It's an abstract situation. It's studied by game theory, algorithms, and so on. So I wonder if there are some studies of this, let's say not of the optimization, but of equilibria of this environment.
Are there any?
In the past, we have been very successful in closing the ozone hole, and there was also no paradigm how to do it. There is no global governance available which could set the stakes, how industry has to behave, and so on. The way it was successful, there was a pressure from the street, in particular in the US. Then there were the identification of the industrial companies which are producing the precursors, and these companies had been brought together with very, very soft pressure in order to come to conclusions, to come to substitutes, to bring them on a roadmap, and that needed a lot of creativity in planning such a process, because there is no governance. And of course, in the climate debate, we have learned from this, and we try to do it in a similar way, but it's a little bit more complicated in the climate debate. Yeah. But there is no other, without a global governor, there is no other way to do it, unfortunately.
Well, maybe it's not unfortunate that there is no global government.
I agree.
Thank you.
I might just offer
okay.
one more comment. Decisions are made in the marketplace by people. I think as an educator that education is important. Our ability to spread evidence and non-fake news, I think, is the importance of journalism, as we heard. But more broadly, I mean, companies are changing practices, moving away from certain types of, say, chemical products, chemical feedstocks within their supply chain, using life cycle analyses to examine because their consumers are demanding it. And so these decisions in the marketplace are also major disruptors. And I think we're going to see that more and more and more. Of course, this crosses boundaries and is much faster to happen, oftentimes, than the development and implementation of regulation.
Thank you. Any questions? Okay, just please wait for the microphone. Thank you very much.
Thank you very much. I would like also appreciate this activity organized by Professor Klánova. I am from his Department of Geography, and I'm former president of International Cartographic Association. We are people who are doing maps, working with data, elaborating remote sensing data, and so on and so on. And I would like to say that I like very much that in fact all of you are thinking also behind the borders of your discipline. And you mentioned several times infrastructures. For me it is data, information infrastructures developed by President Clinton a long time ago. In Europe we have Inspire and we have Copernicus. And don't be so sad that we already have not some infrastructure, because you show first slide here with 17 Sustainable Development Goals from United Nations, and another activity is disaster risk reduction, so-called Sendai framework. And these activities are already supported by a project of UNGGIM. It is Global Geospatial Information Infrastructure. So I think there are not still information you talk today about, but I think in the future it will be part of integration. So some infrastructure is existing and going on. In Czech Republic, for example, I see people are interested very much about SDGs, and there are many activities, no so much time to talk in details. But what is not developed enough, it is disaster risk reduction. Maybe it is because we have not just so many horrible disasters like India, China, and some other countries. But some infrastructure existing in Europe, as I mentioned, INSPIRE, and in the world, coming from United Nations, it is that GGIM, Global Geospatial Information Management. Just to add some optimism to your optimism. Thank you very much.
Yeah, let me. Yeah, I'm sorry. I mean, if you understood that, I was saying that there were no infrastructure. Of course, this is not the case. There are many infrastructure in Europe and worldwide, and there are some that have been newly developed, including here in Brno. Therefore, of course, there are. But what we meant is that we should develop more these infrastructure, and we should develop eventually new infrastructure if needed. So, and this is because this is for the good of all the scientific community, and not only for a single lab.
Okay, so we have like time for last question. Okay, we have two. Okay, so let's do the two.
Hello. I work as the head of air quality department at the Czech Hydrometeorological Institute, the Czech National Weather Service. And what I wanted to say is not really a question, it's just like a remark that sometimes I have a feeling that people do not understand the complexity of the problems. And I wanted to mention three different examples. One is the heating, because here in the Czech Republic, the major issue with air pollution is local domestic heating. It's not industry, it's not traffic. And so we talked about the coal power plants, and I'm of course totally agree with shutting down the coal power plants, but then there is the issue of affordability. We have alternative sources, but what we're seeing now, and given the fact that I just moved out of the city of Brno last year, and I see it now firsthand, people have the option, if we shut down coal power plants, we will have renewable sources. But the problem is that what we're seeing now in our country is that the prices of electricity went up 3 times the end of last year. So I said, okay, I'm not paying that either, because I use electricity for heating. So what I did, I ordered solar panels, which is great, but most people will not do that. It's expensive if they don't believe it or they can't afford it. What they're doing is they're taking out old boilers, stoves that they have in their basements that they shut down decades ago, and they started heating in this. And that, of course, overall, makes the situation much worse than it was previously with the coal power plants. So I'm not saying we should maintain the coal power plants, I'm just saying that we have to make sure that the solution is affordable. Not to mention the fact we had subsidies for new boilers. Most of them, or people bought gas boilers. Okay, now within 1 or 2 days in February, the situation completely changed. So what we're going to do now with gas boilers? The next question is with regards to waste. I also participated in some conferences that were related to waste management. And one thing that was mentioned there repeatedly was that we, for example, built some factories, some recycling plants, and they're very effective. They can recycle things, and then they create this recycled material. So everything, up front until now, everything works. But the problem is that no one wants the recycled material, because they said that it's, for example, it was regarded with plastics, and they said that plastic, okay, it's not that great. It's not 100% the original. It's like a recycled paper. It doesn't look that great. And for example, car manufacturers who could use the recycled material, they said they're not using it because people want the absolute best option. So that's the third problem, and sorry, this is the second problem, and the third problem is communication, and I think that was already mentioned here, that I think that what's the solution is that it's not rules, because people will always try to find how to avoid rules, how to do something differently, especially in this country, we're specialists on this, and always I think that whenever we had COVID, everyone here was an epidemiologist, and then everyone now is an expert on wars and a defensive system. So I think that the solution really is to try to persuade people, and once they believe something, they don't need rules, they'll believe in that. And what I see very often, for example, is that we talked about chemicals, and people think that everything that's natural is good. So they say, okay, but I use wood for heating. And they think that they believe that if they use wood for heating, it's a natural thing, and it must be absolutely great. But obviously the point is here that it depends on the combustion process, not really on the material as much. So yeah, that's the thing that what I see is that sometimes we only see the thing from one perspective, and then it can cause all sorts of other problems and very unexpected outcomes.
You see, very often when we speak to people, when we in environment and health or whatever, we speak to people, people tell me, I was so depressed by what you said. And now we try to be a little bit more optimistic, and now you're telling us you are maybe too optimistic. So we have to find the right balance. I agree with you.
There was somewhere there, but you can ask. Sorry.
Hello. My question is pretty easy. Now you mentioned nuclear industry as green alternative. We can say something about that, because nowadays with the problem with the energy, so can be a good alternative regarding the other.
So what do you think? The nuclear energy.
Coming from France,
yeah. For this,
it's really a big issue. Of course, France says we have nuclear energy, so this is nowadays. But of course there are problems with nuclear energy. I happen to be also in the heading a scientific committee of the institute that works on radio protection in France. But of course, it cannot be a long-term issue, because but for a certain time it may be still very helpful to limit the gas problem and the climate problem. But we have to consider that it cannot last also, because there are very serious issues related to nuclear energy. So it's a balance of timing. Planning in time and seeing how we can stop the fossil and do something different, and then stop that different thing to do something really much better in the future. It's a question of time.
The balance is always crucial.
Yeah.
So okay.
Just one ethics problem. You said before about the communication, but we saw with the COVID and the journalists create this mess regarding the communication, something like that. And you say with a better, education, it could be a better education. But it's not always true. So my question is how we should communicate with the normal people about science. And because my scare nowadays is in some despotic book, like Who Watched the Watchmen, so who control the communication, something like that. So we are scientists, so we should create some contact with the normal people. And my question is, how?
Okay, so how should the contact with normal people look like, according to you?
Well, I actually think that expertise is important. And so my approach is to work oftentimes with community health education specialists. CHESS is a designation given to individuals that work in public health. Because this is not my expertise, this is their expertise. And so partnering with people that know more about the approaches, how to be more effective, has always been the best strategy for me. But certainly I'm not the expert, and hope to continue to learn more in terms of effective communication with people about important intersections of environment and health. Thank you.
And any other comment?
Well, if you have 1 minute on TV, it's really difficult to explain the complexity. If you have more time, all of us probably go. I go to in associations and people in different small cities sometimes, and people come and ask questions. And if you have time, you can explain the complexity and even the uncertainties and what to do with that. It's really really important. I think we need to have ambassadors, more or less. People that learn more and citizens, I mean, I'm talking about citizens that can be then ambassadors toward other, but we have to communicate with the people, that's for sure. I think it's our mission as scientists too.
Okay, so another question from Pavel Jungwirth.
Okay. Kateřina, I'm really happy that you brought up the war in Ukraine, because I think otherwise it would be this elephant in the closet. And hoping that eventually we'll win it and it wouldn't kill us. There are these two possible outcomes, right? Either what doesn't kill you makes you stronger, or what doesn't kill you cripples you. And we were discussing it in the realm of energy and maybe, and you said crises are opportunities. So how do we ensure, like hoping we'll manage this, that it will go the way what doesn't kill you makes you stronger, and not that we will remain burning coal forever, and etc. So yeah, any ideas how to gauge it towards getting stronger from that?
No, I mean, of course, for the people who are suffering now immediately, I mean, this will not, I mean, this is terrible and it will remain terrible, whatever. But I think if you think about it globally, if it's an opportunity to make people aware that we should go much quicker into, you know, these alternative energies, then that would have been something. I mean, this is what they say now in France, that they will increase the speed at which they will develop these new energies. So let's hope this happens. And if that, maybe it will be a push to do that. I don't know.
Okay, so there is another question.
I'm sorry, I came late because I'm working at the hospital and I was busy. But I have a comment to your discussion regarding the approach. I think that what is very important is the national mentality. That is very different. I'm from Slovakia, I live here, I lived in France. And so the mentality is different. And we have a research on extreme stress, on Holocaust survivors, 3 generations, and we see in 3rd generation, 50 years, born 50 years after the war, a difference to the rest of the society. So I think it would be very important to develop national approaches to this problem.
Thank you. So do you agree? It's necessary to develop national approaches?
I fully agree that cultural settings are very important, but unfortunately this mankind went for an experience which requests really global solutions. That was not intended, but it happened. So we need to find solutions beyond our boundaries. There's no other choice, I think.
Okay. Any other questions?
It's not really a question, but since we are probably approaching the end of the discussion, maybe that is an important take-home message, because what you said is closely related to the social aspects that we discussed earlier. And I saw in one of your presentations the word transformational change. And it is a very important issue for communication as well, because governments very often, when they are talking about transformation now, they are talking about transformation of the economics, maybe new innovations that are needed. But I think societal transformation is crucially important, because the businesses, they respond the same way like the policymakers. That's not only about money. Nowadays, the businesses, they also want to have the positive attitude of the society. So the same thing that we need to say to the policymakers, we also need to say to the businesses. And very often they are now really volunteering. They want to be involved in the research. They even would invest into the new research just to create a positive view of the society. But I think it is very important to approach the society. This is really what we are trying to do here, building, the population studies, engaging local businesses and policymakers, but the citizens. But at the beginning, I said that I'm very happy to see people from all the faculties of the Masarykovou University. I hope that the follow-up will be better collaboration across the faculties. Because sometimes I say that the faculties are the biggest obstacle of the future development of the university because they work in silo. They focus on their issues. But we've been discussing for almost 2 hours about the need to work across the domains, to communicate together. And that's the only way forward. Thank you.
Thank you very much.
On what else they should concentrate than on their issues, right? It's natural.
Yeah, it is, but at the same time we need to work together because none of these global challenges will ever be solved without the collaboration across the boundaries. So we need to work together towards the solutions.
Well, I agree with both of you. Okay. We need to go deep, but we need to integrate. We have historically taken reductionistic approaches to scientific inquiry. We need to embrace system-based approaches. We are talking about today issues that are profoundly embedded in systems and systems of systems. So we can still go deep in our discipline. We can embrace the types of approaches that have led to innovation. But if we're not also taking a systems level approach, looking for partners that understand issues, facets of these really wicked, in some case, challenges that we cannot engage by ourselves, then we're losing opportunities, we're losing time, and quite frankly, to your point, businesses will also lose marketing opportunities.
Okay.
Can I add something? I mean, I think, just to comment on the business part, I think, yeah, business can really be very helpful at one point or another, but in some cases you have to just give them a small push. For example, let me give you an example of something we call Nutri-Score in France. Nutri-Score is when you buy food, anything, you go to the supermarket, you buy food, you have if it's an A, it means it's very good from a nutrition point of view. If it's a D or E, that's not so good, and there's a color code. Very easy, everybody can use it. This was pushed by scientists. They pushed it. They were opposed, you know, very strongly in the beginning by industry. But then it ended up, you know, politically, the government did it, and now many industries are taking this as an opportunity because, you know, if they have A's, I mean, decreasing some salt, decreasing fat, etc., and have A's, that's a fantastic opportunity for them to sell. So, yeah, I think we can work together.
Okay, so I think our time is off. So thank you very much for sharing your knowledge, sharing your ideas. It was an amazing afternoon. So our speakers, Professor Bryan Brooks from Baylor University. Professor Gerhard Lammel from Max Planck Institute and Resetox Masarykovou University. And Professor Robert Barucki from INSERM Paris and Paris Descartes University. Thank you so much. And thank you all for coming, for listening, and for asking questions. Now we will follow the 3D projection, so just wait for the special 3D glasses and enjoy the rest of the afternoon. Thank you.